All right, let's see how this goes. So hopefully this shadow doesn't get too bad. This should be a much shorter video than the last one. So I don't think the sun's gonna go down that much while I'm talking. All right, the law of cosines. So pause me and write all of that down. The law of cosines. Pause me. Okay. Oh, let me do this. Ah, look at that. Okay. These are all basically the same formula. It just depends on what information you're given. So if we're given all three sides, we're going to have all of these lowercase letters, right? All of these lowercase letters, and we're going to be solving for the one missing variable, the angle. If we're given side angle side, that's actually the much easier case, and I'll show you that in a minute. So one thing to notice is that in the formula, the side is the same as the angle all the way across from it in the formula. And that's kind of how I remember, because that's what happens in the triangle, right? So little a is across from big A, which happens in the picture. Little b is across from big B, which happens in the picture, and so on. The rest you kind of just have to memorize, okay? And it's a pretty easy pattern to memorize. So let's do it. Side angle side and side side side. So hopefully you remember what the setups are for the law of sines by now. And then now we have two setups that are going to indicate we should do the law of cosines. So we can see here we have side angle side. So that's how we know we need to do law of cosines. And then the side across from the angle, B, is going to be, so it's across, right? We know the angle. We're going to look for the side across. That means we're going to use this formula. Oh gosh, that's very shadowy. We're going to look for this. Let me see if I can turn the light on. Let's see if that helps a little bit with the shadows. We know angle B. We're going to be looking for the side across from it. So that's how I know to use this formula. I know angle B, so I'm going to use this formula right here. So I'm going to go, I'll write it out for you. The more you write it, the faster you will remember it, right? And recognize here, I know A and I know C, and I know angle B, obviously, right? So I'm literally just going to plug in A squared plus C squared minus 2AC cosine of B. Okay, and then I can actually do this one without a calculator, except the answer is going to be kind of wonky because this is going to have a rad 2, and then I'm not going to be able to combine it with that. So I'm just going to bust out my calculator. If you have a scientific calculator, you're going to probably have to do some steps. Oh good, you can still see that. Let me scooch this up a little. I'm going to go 2 squared plus 4 squared minus 2 times 2 times 4 times cosine of 45. Make sure you're in degree mode again. I just want to double check this. Yep, I've got that right. So B squared is going to be equal to 8.6862915, right? And then I'm going to take the square root of that answer, and I'm going to get 2.947. So I'm going to label that on my picture. And then at this point, I could use the law of cosines again, but I think you're all going to choose to use, do you hear that? The guy across the street is like grinding metal right now. It's a great environment for learning, you guys. At least I have some calming music on in the background, right? All right. You could try and use law of cosines again, but I think that you would law of sines is a little bit easier because now I have the angle side pair that we talked about so much in the 8.2 lessons. So I can go sine of 45 over 2.947 equals, right? Now I get to pick. I know side C and I know side A, so it doesn't matter what I do at this point. I could do sine of A over 2, or I could do sine of C over 4. Doesn't matter. I'm going to go alphabetical. Right? There's no reason that I chose that. Cross multiply and solve. I'm going to skip some steps because we have been doing this a lot in the last few days. So cross multiply and then divide to start getting the a by itself. And then we need to do sine inverse of both sides to finish getting a by itself. And then I'm just going to punch that into the calculator. So I'm going to go sine inverse. And again, if you have a scientific calculator, you might have to do this in a few steps. Actually, I could go like this. Look, I'm going to be even more accurate. Hold on. I could go use the ants button. And I'm going to get that angle A is 28.675 degrees. So I know this is 28.675 degrees. And I have, so now I'm looking, I have all the sides. All I need left is angle C. And you guys all know how I can find the angle C, right? C is going to be 180 minus 45 minus 28.675. So 106.325. So there's my missing information. I was given 3 pieces of information and I found 3 pieces of information. 6 total in a triangle, right? Double check, just like we did with the law of sines. Largest angle, longest side, smallest angle, shortest side. And then obviously the middle matches up, right? Okay, let's see if I can squeeze B in here. I'm probably going to regret trying this, but I'm going to do it. I'm going to do it. All right. We're going to go side, side, side. Okay, we're given all 3 sides. That is a 9. Okay, A equals 9. B equals 6 and C equals 4. So that's the given information. Let's draw a picture for that. I have no idea how this is going to work out. I mean, I do know that the longest side is going to be across from the largest angle. So already this is not going to be to scale, right? Because I have it labeled that this is the largest side, but that's okay. We just need a visual. 9, 6, and 4. So now it doesn't matter which formula I choose because I have all 3 sides. So no matter what, no matter which of these 3 formulas I choose, I'm going to have all of the information. I'm just going to be missing the angle. So again, I'm just going to go alphabetical. There's no other, like, if you're going to make a choice, why not make it based on the alphabet, huh? So I'm going to solve for angle A first. I'm going to use side A. My 9s are looking awfully like A's today. Side B. Make sure you're not getting the B's mixed up with the 6s, okay? I personally think it's pretty clear what a B and a 6 is in my writing, but just, yeah. And then side C, minus 2 times B times C cosine of A. Now, be careful. The biggest mistake, this is a pretty easy section, but the biggest mistake that people make is they want to go 6 squared plus 4 squared minus 2 times 6 times 4 and get a number for that, and then plop that number in front of cosine A. We can't do that. We can add these together, but we can't do this subtraction because there's multiplication attached right there. Okay, multiplication always has to happen before addition and subtraction. So since this is attached, we can't do that. So 6 squared plus 4 squared. It's evening and I'm tired and I've been working all day, so I am using my calculator. 6 squared plus 4 squared is 52. I'm allowed to do that, right? 52. And then I'm going to go minus 2 times 6 times 4. Now I'm really being lazy. I knew that. 48. And then the cosine A. Guess what? I'm not going to do 9 squared on the calculator. Okay. Now I need to think I'm solving for A. When I'm solving for a variable, I do reverse PEMDAS. So I need to get rid of this 52 before I can get rid of the 48 because this is attached with multiplication. This is attached with, well, technically it's addition, but it looks like subtraction. So I'm going to subtract 52 from both sides. Okay, subtract 52 from both sides. Then I can divide to get rid of this multiplication here. And then I can do cosine inverse. And I don't ever check to see if that's reducible because that's not part of my answer. I'm just going to type it into my calculator. Cosine inverse of 29 over negative 48 gives me A equals 127.169 degrees. I hope you guys can't hear that as loud as I can. He's like pounding stuff now. Oh boy. 127.169 degrees. He's a firefighter, so I'll give him a break. Okay, now I have an angle pair. An angle side pair, so I can use the law of sines. I could use the law of cosines because I have side angle side, but I don't prefer the law of cosines. I prefer the law of sines. So I'm gonna go sine 127.169 over the side across. And again, I get to pick because I could find angle B using side B, or I could find angle C using side C, right? So I'm going to go alphabetical again just to be consistent. Okay. I'm just going to multiply both sides by 6. Let's see. I'm going to use a different color for that. If I just multiply by 6, that's the fastest way to get rid of, I don't even need to cross multiply at that point. So, and then I'm going to take sine inverse of both sides. Let's see if I can squeeze this in. Let me make it more evident that I'm crossing that off. Okay, and then I'm just going to punch that into my calculator. I'm going to do it again. Hold on. Sine inverse of 6 times sine of that angle divided by 9, 32. So B is 32.089 degrees. And then I'm going to do 180 minus. Write this down if you're worried you're going to forget it. But I'm going to do 180 minus the B minus the A to get me the C. 742 degrees. Okay, so pause me for a second and write that down. Angle C equals this stuff. And then double check. Largest angle, longest side, that checks out. Smallest angle, shortest side, that checks out. So then obviously the middle is going to check out. So I didn't box in. Oh yes, I did box answers. So I got A down there, I got B right there, and I get C right there. Okay. Is that a lot easier? I hope so. And there's no ambiguous case or anything for the law of cosines, so don't worry about that. All right, so I hope you guys are good.